Hi, I'm Hal Aronson with the Solar Schoolhouse, and we're out in the sun, and we're here today to teach you how to use the multimeter. The multimeter is a terrific electrical diagnostic tool. It measures volts, amps, resistance, continuity, all kinds of information that you would like when you're working with electricity. So let's look at the features of this multimeter. First of all, you've got a selector knob that lets you choose between a variety of options here, depending on what you're measuring. Secondly, you have the ports here. The black lead is always in the common port, and the red can move around. On this side, in this port here, you can see it says V, then the resistance symbol, then milliamps. So we use this side primarily to measure voltage, and this side, you can see it says 10 ADC, and what that stands for is 10 amps DC current. And we use this port when we're measuring amperage. And finally, on the top we have the screen. And when this turns on, you get your readings. That's where you get the information. It's important to always have your meter off when you're not using it, because it does run on a battery and you don't want to run that down. So the first thing we're going to measure is voltage. Now, I know that this battery produces about 1.5 volts. And you can see that on the DC voltage scale, you see, if you look here, you see a V in a straight line and a broken line. That's the symbol for DC voltage. If we swing over here to the right, you see a voltage sign again, but you see that squiggly line? That's the sine wave, and that represents AC voltage, alternating current. We're not measuring that. We're measuring DC voltage. You've got this little white scale here. Everything over here is volts. What you want to do is set your scale closest but greater than the amount of volts that my battery can produce. So I'm going to choose the 2 position. I check and I make sure that my red lead is in the volt position, touch the black lead from the voltmeter to the back of the battery, and the positive to the front, and now I've got a reading. And if you look on the scale, you'll see it's reading 1.227 volts. What would happen if I reversed polarity? What if I put my negative lead to the positive side of the battery? So let's try it and see what happens. If you'll see, we get a reading of negative 1.2 volts. This lets me know which side is positive and which side is negative. This is also a really nice opportunity to demonstrate series wiring. Let's put these 2 batteries together in series. If they're each about 1.2 volts, I'm going to guess that they're going to be over 2 volts total. So my 2 volt scale is not going to work anymore. So I'm going to move it over to the 20 volt scale. And I put my probes on there. And you'll see we now have 2.45 volts. So basically the voltage added up. Series wiring adds volts together. Okay, so now we're going to measure a solar cell using the multimeter. So here's the positive lead, and here's the negative lead. We make sure that we're in the volt port, which we are. And I know this cell puts out about 0.5 volt. So I'm going to go ahead and shift my meter to 2, plenty of voltage. And I just put the positive lead to the positive side of the cell and the negative to the negative. And we can see the voltage. About 0.56 volts open circuit. Now let's measure how many amps this solar cell can produce. To do that, I need to get to the amps DC side. So I move this over. And now I'm going to go to the amps position. See how this says 10 ADC, 10 amps DC? Now there's a 10, this is the amps section of the meter, and there's a section that says 10A, that stands for 10 amps. So you move the dial over to the 10 amps, and we're ready to go. We hook up our positive to the positive side, our negative to the negative lead. And this is a really nice moment for solar. You see how we're getting a reading of amps? So right now we're getting about 0.18 amps. Now the amount of current, or the amount of electrons flowing, is determined by how much light hits the cell and the size of the cell. Watch what happens when I aim the cell more directly into the light. I'm getting about 0.39 amps. So the more light that hits the cell, the more amps that I produce. So we now know this thing produces about 0.5 volt and up to about 0.4 amps. Now this is a great opportunity to show you a little parallel wiring. To just show you that in parallel wiring, you add the amps of the cells together. So in parallel wiring, we connect the 2 negatives together. And after I do that, I'll put the 2 positives together. And then we're going to put it up in the sun. And you can read the amperage. You can see we're getting about 0.76, 0.77. You add the amps of the cells together. So let's just do a quick example of series wiring and measuring it with the voltmeter. So we take our positive and negative and put it together. And we already know that each module, each cell puts out about 0.5, maybe 0.56 volts. So the two together will produce approximately 1 volt. So we go to our meter and we put it to the number 2 volt scale here. And we take our positive lead and our negative lead, and we put the negative onto the negative wire that's left on one end and the positive on the other. And lo and behold, it's reading 1.1 volts. Now while we've got this set up, we can check the rule that even though volts are added, amps should stay the same. And what we can do with the same setup here is now measure amps. So I turn the meter to off. I pull out the probe from the volt side and put the lead into the 10 amp side. And then I put it to the 10 amp position, and we can read amps. And I'm going to go ahead and move it to maximum sun so that we can actually be honest about this. And when I turn it to here, I can get up to about 0.35 amps, 0.36 amps. And since we know with our parallel example that when you put two of these together in parallel, we're going to get more like 0.7, 0.75 amps, we can see that we haven't exceeded the amperage of a single cell. Finally, we're going to measure continuity. In continuity, what you're going to do is you're going to measure whether or not electricity can flow through a circuit. The symbol that we're going to be using there is the resistance symbol right there on the dial. And we're going to put it into this port. This port, the other port, is only for amps DC. It's not for anything else. And then we're going to see if electricity will flow. Here, let me set it up. We take the meter and we put it toward that thing that looks like the symbol for sound. And when we find continuity, it's going to give us a sound. You can see you get continuity here because there's perfectly no resistance to the flow of electricity between one lead and the next. Let's try on a screwdriver. So a screwdriver would be a good electrical conductor. How about if we went between the screwdriver and its plastic handle? No sound. Electricity can't flow here. Never use your continuity tester on a power source that has electricity available in it, such as a battery or a solar module, because you'll end up running the electricity right into your meter, and that could cause problems. Sometimes you'll create this nice setup and it won't work, and it turns out that you have a defective jumper. So the way to check a jumper is to put one end of the continuity tester to one lead and the other to this lead, and we get a good signal that tells us that electricity will flow well. So this jumper is good, so you can use this. Now we're going to test a solar module to see if this one is in good shape. And this module tells us that its open circuit voltage should be about 21.6 volts. And it shows us that its short circuit current should be about 2.05 amps when it's in optimal sun. We don't have quite optimal sun right now. It's a winter day, but we can at least see if we can approximate those numbers. So I need to go above 20 volts on the scale. So on the volt scale, I'm going to put it to 200. Make sure that the volts is in the volt port. And now I'm just going to hook positive to positive and negative to negative, and give the solar panel some light. And you can see it says 21.2 volts. They told us we'd get 21.6 volts, so we're very close. Now with this thing still hooked up, we can switch it to do an amp measurement. We turn it off, take our lead out of the volt port, put it into the DC amp port, and then we put it to 10 amps DC. Turn this thing into the sun, and let's see how many amps we get. Right now we're getting about 1.2 amps. And they told us we'd get about 2.05, so we're very close. And given that we're not an optimal light, this suggests that this module is very healthy.